Another day, another fascinating discovery by the James Webb Space Telescope that challenges our theories of the early universe. The telescope's ability to look further back in time than any other telescope to date, along with its high sensitivity, is helping us unfold the universe like never before. And I don't say it lightly, no sir. The telescope has helped a team of scientists from the Massachusetts Institute of Technology to observe light that has been traveling to Earth for 13 billion years. The universe itself is 13.8 billion years old. Now, that wouldn't be a big deal if the light that has been observed wasn't from stars surrounding some of the earliest supermassive black holes in the universe. But it is. Since it spotted 6 quasars sitting at the hearts of active galaxies, the observations also revealed that the cosmic giants are insatiably feeding on the surrounding materials of the galaxies they host, generating intense accretion disks and thereby powering the quasars. Not just that, these black holes have grown to tremendous masses equivalent to millions, sometimes even billions, of suns. And this is where the questions begin to surround our models. You see, according to our models, a standard black hole forms when a star runs out of fuel and undergoes gravitational collapse, triggering a supernova. The resulting black hole then gradually consumes material throughout its lifetime, growing over time through mergers. And that process should take billions of years. But the supermassive black holes observed here are present only a few million years after the Big Bang, and they are huge. How did that happen? One theory suggests that these black holes began forming early, originating from what are known as heavy seeds black holes. The MIT team used Webb to study faint starlight from the galaxies hosting these ancient quasars, providing the first evidence that supermassive black holes in the early universe grew from these heavy seeds. This is what Anna Christina Isas, a scientist from MIT, said in a statement. These black holes are billions of times more massive than the Sun at a time when the universe is still in its infancy. Our results imply that in the early universe, supermassive black holes might have gained their mass before their host galaxies did, and the initial black hole seeds could have been more massive than today. This sheds light on what came first. Did the black hole expand first with the galaxy following suit, or did the galaxy and its stars grow first, influencing and controlling the black hole's growth? It appears that black holes in the early universe were expanding more rapidly than their host galaxies. This suggests that the original black hole seeds may have been more massive at that time. But a major question still remains: how could these enormous black holes grow to such size so quickly? There must have been a mechanism for black holes to accumulate mass earlier than their host galaxies in the first billion years. One proposed mechanism is called direct collapse. In this model, rather than a star collapsing to form a black hole, a massive cloud of dust and gas collapses, skipping the star formation stage entirely. This process could potentially create much larger black holes, allowing them to become supermassive earlier than otherwise would be possible through conventional means. While this concept is still theoretical, astronomers in 2023 announced the first candidate for a galaxy containing a direct collapse black hole. And now, with this JWST observation, we might be looking at a whole new chapter of black hole formation science. While this discovery from the edge of time challenges our theories, a recent discovery of a black hole closer to home has scientists. Back in 1975, two titans of astrophysics, Stephen Hawking and Kip Thorne, engaged in a fascinating bet over a cosmic mystery known as Cygnus X-1. Intense X-ray emissions from the object prompted Thorne to speculate that it might be a black hole. In a playful challenge, Hawking bet against him. Cut to the early 90s, and several observations revealed that Thorne's intuition was spot on. Cygnus X-1 was indeed a black hole, at a distance of 7,000 light-years away from Earth. Remember the distance because we're going to talk about its significance very soon. This discovery not only confirmed the existence of black holes but also powered the field of X-ray astronomy, unveiling a new way to explore the cosmos. Today, we know that Cygnus X-1 is a captivating example of an X-ray binary, a cosmic duo consisting of a voracious black hole and a massive star. The star, in its prime, shed some of its material, creating a swirling disk of gas and dust that spiraled into the black hole. This process generated intense X-ray emissions and powerful jets of particles we later observed from home. But how big is Cygnus X-1? Today, with advancements in technology, we can now confirm that Cygnus X-1 is approximately 20 times the mass of our Sun. Until now, Cygnus X-1 enjoyed the status of being the most massive stellar black hole in the Milky Way galaxy. But now we have found another monster, much bigger than Cygnus X-1, and it lurks much closer to home than its predecessor. In an accidental discovery, scientists have found a massive stellar black hole lurking close to Earth. This quiet monster was discovered using the European Space Telescope Gaia, which tracks the movements of billions of stars in our galaxy. What's significant about this find is that it represents the first time that such a large black hole with such an origin has been found near Earth. There are quite a few stellar black holes scattered in the Milky Way, and on average, they are about 10 times the size of our Sun. As discussed in the beginning, we know that Cygnus X-1 is about 20 times the size of the Sun. This newly discovered stellar mass black hole, which has been designated Gaia BH3, is 33 times more massive than our Sun. So not only is it twice as massive as the average stellar mass black hole in the Milky Way, it is almost twice as big as Cygnus X-1. Now let's talk about its distance. Gaia BH3 is located just 2,000 light-years from Earth, making it the second closest black hole to our planet ever discovered. And which one's the closest black hole to Earth, you ask? That's Gaia BH1, which is 1,560 light-years away but has a mass around 9.6 times that of the Sun, thus making it considerably smaller than Gaia BH3. But how did we discover it suddenly after so long? Gaia's Black Hole Task Force was looking for odd wobbles in stars that couldn't be accounted for by the presence of another star or a planet. That indicated the presence of a much bigger and heavier companion, possibly a black hole. Focusing in on an old giant star in the constellation Aquila, the team found a wobble in the star's path which suggested that the star is locked in orbital motion with a dormant black hole of exceptionally high mass. The two are separated by a distance that ranges from the distance between the Sun and Neptune at their widest, and our star and Jupiter at their closest. "It's a real unicorn," said one of the scientists. This is the kind of discovery you make once in your research life. But here's the shocking bit, Gaia BH3 might not be alone. Gaia's next data release is expected to contain many more, which should help us to see more of these dormant stellar black holes closer to home. So far, black holes this big have only ever been detected in distant galaxies by the Hubble and James Webb telescopes. If humanity is to make space its frontier, understanding black holes is the key. More data from the James Webb telescope will help us understand these cosmic giants better. What do you think? Drop in your comments below and don't forget to subscribe to Bright Future, because this is your space.